Hello everyone, this is John Hashmat and welcome to Physics Simply. In this video, I will be solving the paper 2 exam for May-June 2016 variant 1. So let's get started. Question 1 says a diagram shows an enlarged drawing of the end of a meter rule. It is being used to measure the length of a small feather. What is the length of the feather? The start here is at 10 and the end is at 29. So 29 minus 10, that gives us 19. But the numbers on the top are in millimeters, so that is 19 millimeters, not 19 centimeters. So we choose A. Question 2 says the speed time graph shown is for a car moving in a straight line. What is the acceleration of the car when the time is 40 seconds? So at 40 seconds, this is the point, and the acceleration is calculated as the gradient of the speed time graph. So the gradient at this point is actually 0 because the line is horizontal at this point. So the acceleration is also 0, so we choose A. Question 3 says two runners take part in a race. The graph shows how the speed of each runner changes with time. What does the graph show about the runners at time t? So at this point here, we have the same speed at the same time. Both runners are moving at the same speed, yes. Runner 1 has 0 acceleration, no, because the line is inclined, there is a gradient. The gradient is not 0, so this is wrong. Runner 1 is overtaking runner 2. That means it covered the same distance, but the areas under the graph are different until time t, so it is not the same distance, so not overtaking. Runner 2 is slowing down. No, the graphs here are going upwards, so this means that both runners are accelerating or the speed is increasing, not slowing down. So the answer here is A. Question 4 says a satellite orbits the Earth above the atmosphere at a constant speed. The diagram shows the satellite at one point in its circular orbit around the Earth. Which labeled arrow shows the direction of the resultant force on the satellite at the position shown? So any object moving in a circle with constant speed, it has a centripetal force that is pointing towards the center. So we choose D here, pointing towards the center of the Earth. Question 5 says a cup contains hot liquid. Some of the liquid evaporates. What happens to the mass and what happens to the weight of the liquid in the cup? So the number of molecules decreases due to the evaporation, so the mass decreases. And the weight is proportional to the mass, so the mass is also decreasing. So we choose here A. Question 6 says the diagrams show three uniform beams, P, Q, and R, each pivoted at its center. The two forces acting on each beam are also shown. Which beams rotate clockwise? So we need to calculate the clockwise moments and the anti-clockwise moments. So for the clockwise moments here, we have 4 multiplied by 1, that's 4. And the anti-clockwise moment, 4 multiplied by 2, that is 8. So the total moment here is anti-clockwise, not clockwise. For the second one, we have 5 multiplied by 2, that gives 10. And on the other side, we have 2 multiplied by 4, that gives 8 again. So this one has a clockwise moments greater, so this one will rotate clockwise. For the last one, we have the force multiplied by the distance, 1 times 4, that gives 4. And the anti-clockwise, we have 1.5 times 2, that gives an answer of 3. So the resultant is clockwise. So the ones that rotate clockwise are with the greater clockwise moment than anti-clockwise moment. So that would be Q and R. So not P and Q, not P and R, Q and R only. That is the answer. So we choose C. Question 7 says an object of mass 50 kilograms accelerates from a velocity of 2 meters per second to a velocity of 10 meters per second in the same direction. What is the impulse provided to cause this acceleration? We can use the equation impulse is equal to the change in momentum, which is equal to the mass multiplied by the change in velocity. And we substitute by the numbers, mass 50, final velocity 10, initial velocity 2. That gives an answer of 400 newtons second, so we choose B. Question 8 says a scalar quantity has magnitude and direction. No, no direction. No magnitude, nothing has no magnitude. Magnitude but no direction, yes. So the answer is C. Question 9 says energy is released in some nuclear reactions. Which nuclear reaction takes place in a nuclear power station? That would be fission, not fusion. That would be in the stars if it was fusion. And which nuclear reaction takes place in the sun? That is fusion, because the sun is a star. So the common choice here is B. Question 10 says a lorry of mass 4,000 kilograms is traveling at a speed of 4 meters per second. A car has a mass of 1,000 kilograms and the kinetic energy of the car is equal to the kinetic energy of the lorry. What is the speed of the car? So we can use the equation for kinetic energy, half times the mass times the speed squared. So half times 4,000 times 4 squared, that is equal to half times 1,000 times the other speed squared, and we need to calculate this speed. So we can divide by half on both sides, then we divide by 1,000, and then we square root to remove the square of the speed. That gives an answer of 8 meters per second, so we choose C. Question 11 says a force acts on an object and causes the object to move a certain distance in the same direction as the force, which row represents the situation in which the largest amount of work is done on the object by the force. So we need to multiply the force by the distance in each case and see which one will give the largest number. So 2 times 40, that gives 80, 10 times 2, that gives 20, 20 times 6, that gives 120. 100 times 1, that gives 100, so the largest number here is 120, so we choose C. Question 12 says a diver underwater uses breathing apparatus to a depth where the pressure is 1.25 times 10 to the power of 5 Pascal. A bubble of gas breathed out by the diver has a volume of 20 centimeter cubed when it is released. When it has a pressure of 1.25 times 10 to the power of 5 Pascal, the bubble moves upwards to the surface of the water. At the surface, the atmospheric pressure is 1 times 10 to the power of 5 Pascal, so the pressure changed or decreased. The temperature of the water is the same at all depth. What is the volume of the bubble when it reaches the surface? So we can use the equation P1 V1 is equal to P2 V2, and P1 was 1.25 times 10 to the power of 5, V1 was 20, P2 is 1 times 10 to the power of 5, and V2 is the required here. So we divide the left side by 1 times 10 to the power of 5, that gives an answer of 25 centimeter cubed, so the answer is D. Question 13 is about barometers, so you can skip this question for the new syllabus. It says the diagram shows a simple mercury barometer. The atmospheric pressure increases. Which distance increases? So when the atmospheric pressure increases, the level of the mercury rises in the tube. So it would be W2X would rise, or W2Y would rise, or W2Z would rise. So the options here, VW, not VW, that will decrease. The level above the mercury will decrease, not increase. WY, that is one of the choices we said, so we choose B. And to make sure, XY will actually decrease because the mercury will move into the tube, so this level will decrease. And as for XZ, it is the same concept, so the level in the dish will decrease so that the level in the pipe will increase. Question 14 says which statement about evaporation is correct? Evaporation causes the temperature of the remaining liquid to decrease. That's correct. Evaporation does not occur from a liquid near its freezing point. No, it occurs at any temperature, so this is wrong. Evaporation does not occur from a dense liquid. It does. Evaporation occurs from all parts of the liquid. No, only at the surface, so the answer here is A. Question 15 says a beaker contains 0.500 kilogram of water at a temperature of 3 degrees Celsius. The beaker is heated and the internal energy of the water increases by 21 kilojoules. The specific heat capacity of water is 4,200 joules per kilogram degrees Celsius. What is the temperature of the water after it has been heated? So first we need to calculate the change in temperature using the equation energy is equal to the mass times the specific heat capacity times the change in temperature. If we place delta theta as a subject, it is Q divided by MC. So we substitute 21,000 for kilo divided by the mass 0.500 multiplied by the specific heat capacity 4,200. That gives an answer of 10 degrees Celsius. So the temperature increased by 10 and it was initially 3. So we add 10 to 3. That gives us a final answer of 13 degrees Celsius. So we choose C. Question 16 says a substance loses thermal energy to the surroundings at a steady rate. The graph shows how the temperature of the substance changes with time. What could the portion PQ of the graph represent? So it must have been a gas at first and the gas cooled, then condensed at P until P. Then from P to Q, that would be a liquid state cooling down and then it is freezing. So gas condensing, no. Gas cooling, no. Liquid cooling, yes. Liquid solidifying, again, no. So the answer here is C. Question 17 is about thermometers, so you can skip this question for the new syllabus. It says a student wishes to check the upper and lower fixed points on a Celsius scale thermometer She has 4 beakers P, Q, R, and S. Beaker P contains a mixture of ice and salt. We don't need salt. Beaker Q contains a mixture of ice and water. Yes, that would be useful. At 0 degrees Celsius, the ice is melting. Beaker R contains boiling salt solution. No salt again. Beaker S contains boiling water. That is the 100 degrees Celsius. So we need Q and S. Which two beakers should she use to check the fixed points? That would be Q and S. So the answer is D. Question 18 says two otherwise identical cars, one black and one white, are at the same initial temperature. The cars are left in bright sunshine and their temperature increase. During the night, their temperature decrease. Which car shows the greater rate of temperature increase and which car shows the greater rate of temperature decrease? So for increase in temperature, that would be absorption of infrared radiation. That would be the black surface, which is a better absorber of infrared radiation. And for decrease in temperature, that would be emission of infrared radiation. And again, black surfaces are the better emitters of infrared radiation. So the common choice here is A. Question 19 says a liquid is heated in a beaker. The density of the liquid changes as its temperature increases. This causes the energy to be transferred throughout the liquid. How does the density change and what is this energy transfer process? So when you heat an object, its volume increases, and the increase in volume causes the density to decrease because volume and density are inversely proportional. And this type of movement in a fluid is called convection. So the choice here is B. Question 20 says sound waves of frequency 2 kHz travel through a substance at a speed of 800 meters per second. What is the wavelength of the wave? So the wavelength is equal to the speed divided by the frequency. So we have 800 meters per second divided by 2000 for the kilo. That gives an answer of 0.40 meters. So the answer is A. Question 21 says which row shows the natures of light waves, sound waves, and X-rays? That would be longitudinal or transverse. Light waves are transverse, sound waves are longitudinal, and X-rays are transverse. So the common one here is C. Question 22 says the diagram shows light traveling from air into glass. 4 angles V, W, X, and Y are shown. Which formula is used to calculate the refractive index N of the glass? So the angles are measured from the normal, so we are focusing on W and X. And the refractive index of a medium is equal to the angle in the air over the angle in the medium, sine W over sine X. So the answer here is D. Question 23 says the diagram shows a converging lens forming an image of an object. Which statement about the image is correct? It is not real, it is virtual, and can be seen by the eye at X or Y. It should be where the light is pointing, so it would be at Y. So it is not C, it is D. Question 24 says a sound wave travels through the air as a series of compressions and rarefactions. Which row correctly compares the air pressure in a compression and the air pressure in a rarefaction to the air pressure nearby where there is no sound? So at a compression we have a higher pressure and at a rarefaction it has lower pressure. So the answer here is B. Question 25 says a sound wave has a certain amplitude and a certain frequency. A second sound wave is quieter and has a lower pitch. So the second wave has not a larger amplitude, it has a smaller amplitude and a smaller frequency, not a greater frequency. So the answer is D. Question 26 says what is an electric field? It is a region around the wire carrying an electric current. No, that would be a magnetic field. A region in which an electric charge experiences a force, yes. A region in which electric charge is attracted by the Earth's gravity, no, not gravity. A region through which electromagnetic radiation is passing, no. Electromagnetic radiation is an electric and a magnetic field together, so it's not an electric field alone. So the answer here is B. Question 27 says a negatively charged rod is held close to one side of a metal sphere. The other side of the sphere is Earth. Which diagram shows the distribution of charge on the metal sphere? So the negative rod will repel the electrons and the Earth will attract the electrons. So the sphere will be positively charged at the end with positive charge towards the negative rod. So this is because of the attraction, and the negative charges which were here are taken by the Earth and repelled by the negative charge on the rod. So the answer is D. Question 28 says a cell is connected to a lamp as shown. A charge of 4 coulombs flows through the lamp in 2 seconds. What is the direction of the electron flow in the lamp, and what is the current in the lamp? So electrons are repelled from the negative side, so it would be like this, pointing to the right from left to right. So these are the choices. And as for the current, we can calculate it as charge divided by time. So we have 4 divided by 2, so the current is 2 amperes. So the common choice here is A. Question 29 says the diagrams show 4 current voltage graphs. Which 2 graphs show the characteristics of an ohmic resistor and of a filament lamp? So an ohmic resistor obeys Ohm's law, which says that the current and voltage are directly proportional. So it would be a straight line through the origin. So this is the ohmic conductor. And as for the filament lamp, its resistance increases when current increases, which means it needs more voltage. So it will be bending towards the voltage axis. So this is the lamp. So for the ohmic resistor, we have X, and for the lamp, we have Y, and the common one here is B. Question 30 says the 4 circuits shown all include an AC power supply, 2 diodes, and a lamp. In which circuit is there a rectified current in the lamp? So we need to check if the diodes are working or not, and in which direction. So for example, here the current is only allowed to move in this direction through the diode on the left, and through this direction, which is the same direction on the diode on the right. So these diodes rectify the current in one direction. So it would be like this, one hump and then 0, because it will not allow the current to flow in the opposite direction, and then again. So there is no negative here, so this is a rectified current. As for B, we have the current flowing in this diode in this direction, but if the current is coming from the opposite direction, it can still go back to the power supply through the diode on the right. So this will not be rectified. The current is allowed to move in 2 directions. And for C and D, the current is blocked this way and blocked this way. Again, here current is blocked this way and blocked this way. So these circuits will not work at all. So it is not C or D, and it is not B because it is not rectified. The current can flow in both directions. Only A has current flowing in one direction. So this is the answer. Question 31 is about logic gates, so you can skip this question for the new syllabus. It says the diagram shows a combination of logic gates. Input P is at a logic state 0 and input Q is at a logic state 1. What are the logic states at the output X and output Y? So we go through the circuit. If the input P is at 0, the NOT gate will convert it to 1. And for input Q, that is 1. 1 will enter this gate, which is an AND gate. 1 and 1 through an AND gate will give us 1, but through an AND gate will give 0. So the output X is 0. This is the first part. And this 0 is transmitted here, so 0 entering here, and this 1 goes this way. So 1 and 0 through an OR gate will give 1, but this is a NOR gate, so the output here will be reversed, so it will be 0. So output Y is 0, and the common choice here is A. Question 32 says the diagram shows part of a circuit used to switch street lamps on and off automatically. In the evening, it gets dark. Which row shows the effect on the resistance of the light-dependent resistor and on the potential difference across it? So in a potential divider, we have the voltage proportional to the resistance. So if a resistance decreases, its voltage decreases, and vice versa. When it gets dark, though, the LDR resistance actually increases. When light decreases, the resistance of the LDR increases. So the voltage across it will increase in the potential divider. So the answer here is D. Question 33 says a domestic circuit includes a 30 ampere fuse. This protects the wiring if there is too much current in the circuit. In which wire is the 30 ampere fuse positioned, and what does it do when it operates? So it is always connected in the live wire, and its operation is disconnecting the circuit or reducing the current to 30 ampere. It disconnects the circuit completely because it melts and breaks the connection. So the answer here is A. Question 34 says a strong electromagnet is used to attract pins. What happens when the current in the coil is halved? So halved means decreases, so the magnetic field strength will decrease, so the attraction will decrease. No pins is not correct. There will still be some pins attracted, but not as many. Some pins are attracted, but not as many. Yes. The same number of pins is attracted. No, because the strength of the magnet decreased. More pins are attracted. No, this will happen if the current increased, not decreased. So the answer here is B. Question 35 says the diagram shows a transformer. The input voltage is 240 volts. What is the output voltage? We have 800 turns on the primary coil and 40 turns on the secondary coil. We can use the equation Vs over Vp is equal to Ns over Np, or cross multiplication. So we have Vs required, Vp is 240, Ns is 40, Np is 800. So we multiply 240 times 40 and then divide by 800. That gives an answer of 12 volts, so we choose B. Question 36 says the diagram shows a shaded area where the direction of a magnetic field is into the page. A beam of beta particles enters the field as shown. In which direction is the beam of beta particles deflected as they enter the magnetic field? So we have a magnetic field into the page, and the current, due to the beta particles moving, is opposite in direction to the motion of the beta particles because they are negatively charged. And now we have to use Fleming's left-hand rule, since we have a current and the magnetic field and we need to know the force. If the magnetic field is pointing into the page and the current is pointing to the left, we have the thumb pointing downwards, so the force will be down the page. So the answer is C. Question 37 says the arrangement shown is used to check whether the flour inside the cardboard packet is above a certain level. If it is above this level, the flour absorbs the radiation from the source so that it does not reach the detector. Which type of radiation is suitable to use? So we need a type of radiation that can penetrate the cardboard but cannot penetrate the flour. So it has a medium penetrating power because the cardboard would absorb a low penetrating power. So alpha cannot be used because it will be stopped by the cardboard itself. The detector will always read 0. Beta particles are suitable because they are more penetrating than alpha, but not that penetrating that they will go through the flour and reach the detector. But gamma rays are very penetrating, so they can go through the cardboard and go through the flour without decreasing. And again, we said alpha particles cannot be used, so the answer is B, beta particles only. Question 38 says a nucleus of americium emits an alpha particle to form a nucleus of neptunium. Which equation represents this decay? So we need to memorize the numbers for an alpha particles. It's 4 and 2, not 0 and -1. 0 and -1, that is beta particles, so it is not B nor C. And for the neptunium, we need to balance the numbers. So 243 minus 4, that would give 239. So it is not A, it is D, because the number here is balanced. And to check 95 minus 2, that would give an exact value of 93. So we are sure that the answer is D. Question 39 says a certain element has several isotopes. Which statement about these isotopes is correct? They must have different numbers of electrons, not necessarily. They must have the same number of neutrons, no. Same number of protons. They must have the same number of nucleons in their nuclei, again no, because the number of neutrons is different. They must have the same number of protons, yes, so we choose D. Question 40 says a reading is taken every 10 minutes of the number of emissions per second from a radioactive source. The table shows the readings. What is the half-life of the source? So there is no mention of any background, so we just take the first reading and then we divide it by 2 for 1 half-life. That gives 400. And then we take this value and see at which time it reached this value. So here the answer is 20 minutes, so we choose B. So this was the end of the exam. I hope you enjoyed this video and found it useful. Keep practicing and I will see you in another video.